So hello guys, welcome to our next video in the playlist. So we're going to create a new playlist today called Google Colab. So in today's video, we'll first look it into how does the basic layout of this Google Colab is, and next we will convert our Sentinel 2 dataset, which is having a resolution of 10, 20, and 60 meter per pixel to 1 meter resolution. So we have a ready built-in model which was developed by Yusuf Akhtaman. So he's a part of the Gamma Earth. So it's also the Earth Observation organization of the Google. So let's just start. So here you will see at the very first instance, if you open Google Colab, you will get a tab. So this particular is called as a cell. So where you need to have some codes and you want to run it, and you can also generate it with AI. So the Google Colab comes with the Gemini. It's a own AI assistant of the Google Colab. Google. So either you can start coding on your own, or you just have to tell what you want to the Gemini. It will generate the script for you. You can just copy and paste, and you will have your code ready, and you can run it in the cells. So if you're not just that much into the Python, or you're just a beginner, so you can always use the AI, make use of it. So here you can have one is the code cell, and another one you can have is the text cell. So if you can click on this, you will get a code cell. So if you can just click on this, you will get a text cell. So the text cell is used for writing the text in order to explain what is the cell below his, what does it contain, or what does it to do, what are all the functions it has. So if you want to have some explanatory kind of a notebook, so you can always you make use of this text. So remember, all our notebooks will be in the format of IPy notebook. So it means the Python notebook. So uh, just remember this format. So after doing this, so here you will have one of the files. So currently our Google Colab is connecting to Python 3. So here you can see it's connecting. So before you can run any of the cells, make sure you connect it to the Python CPU, Python 3 CPU. So it is showing the what is the exact available RAM and the disk storage. So whatever your files and output will become in here, this tab, and whatever the variables you create will come in here. So after that, now we want to go for the options we have here. You have the file one in order to open or create a new notebook in your drive. So remember, the Google Colab is a cloud based notebook environment. So whatever the files you just upload or download, whatever will output only will only be in the cloud. So if you want to have it offline, so make sure you download it before you close the Google Colab environment. So here you can save or whatever the basic options you will find in the Microsoft application. So you will also find this in here. So if you come just to edit, so here it is for copying the cell, pasting the cells. For copy pasting and selecting thing, you have the edit tool available. So in the view, you can just show or hide your code or output. So you can just manipulate your outputs, and in the insert one, you can insert the cells, text cell, code cell. So anything you can insert in here. So the runtime, we have multiple options for runtime. Either you can run all the cells which is written in your notebook at once, or you can run a single cell before, after, or run a particular cell of selection. And you can also change the runtime type to the GPU, or the CPU, or the T4. For anything you can change. And you will also have some additional tools for setting up the keyboard shortcuts, and you also have the help for the FAQs, and other such thing for reporting the bugs and all. So we will see one by one how does it works, and how we will can do in the Google Colab. So now currently my environment is collected to Python 3. So let's just see how does this work. So let's say I want to work on some library. I want to work on the vector data. So remember, the GeoPandas is the Python package which is widely used for working with the vector data set. So if I just write import GeoPandas, and click on the run. So I have missed the O, and click on the run. Your cell would start running, and it is executed within 1 second. Within 0 seconds it has executed. So if you get a tick mark, it means that you have come across no errors. The library, which is geopandas, working with for working with the vector data, has been successfully installed. So what if I want to use some of the libraries or the Python packages which are not by default installed in this particular Google Colab environment? Like for example, I want to use a package called Rio X-ray. So it is saying that with some kind of yellow line, you can call it as an error line. So it means this particular module is not installed in the Google Colab environment. So you just click on the run, you'll get an error. So here you will see the error mark. So the error says that the module is not found. No module named Rio X-ray is installed in the Google Colab environment. So I want to install my Rio X-ray. So remember, Rio X-ray is used widely for working with the raster dataset. So if you have a time series dataset, it's usually very easy to work with this Rio X-ray. So how can I install this Rio X-ray in my Colab environment, which is not installed by default? So remember, you can always use this pip, the Python package installer. uh, so also you can use the conda or mamba, anything you can use. So I'm just using the pip installer in order to install my Rio X-ray package. So you just have to write pip install Rio X-ray, and whatever this exclamatory sign I am using in front of the code will run your script in the backend or the terminal. So this will help to the Google Colab to install whatever the mentioned library in your Google Colab environment. So it's running now. So it's collecting the Rio X-ray, whatever the requirements are there. It's all collecting, downloading, collecting, requirement satisfied. So at the end, you will see it is successfully installed. So successfully installed Rio X-ray as well as Rasterio. So Rasterio is again working with the for the raster dataset. You want the Rasterio. So remember, the Rio X-ray is built on two particular packages. One is the Rasterio and another one is the X-ray. So together it's called as Rio X-ray. So this particular code has made my notebook look somewhat cringy. So I want to, though I don't want to have this all these details, whatever the metadata or whatever the requirements are there, I don't want it to be on my Google Colab. So I just wanted to hide it. So I am using this magic command called percent capture. So if you are using percent capture at the beginning of any code which is running in the terminal, so it will hide whatever you have seen earlier. So now I have click on the run. So it's running in the terminal now. You have just got it installed. Your uh, code has run for 5 seconds and the Rio X-ray has been imported. So now if you can just import Rio X-ray, you won't get that error line. So make sure you use proper spellings. So just say import Rio X-ray, your X-ray Rio X-ray is installed now. So it has been imported successfully. So this is how you can install the libraries which are not already by default built in the Google Colab. So like this you can do that. So now we are gonna in the very first tutorial, so we are gonna convert our Sentinel-2 dataset, which is at 10-meter resolution for the four bands, and for the rest of it, it has 20 as well as 60-meter band resolution. We will upscale the Sentinel-2 dataset to 1-meter resolution with the help of s2dr3 model. So the s2dr3 is a model which is very based on the deep learning framework. So it is designed to enhance the spatial resolution of Sentinel-2 imageries. So as I've already told you, it is developed by Yusuf Akhtaman, so one of the very important persons in the Google Gamma Earth, and it will convert the first 12 bands, so except the B1, from B2 to B12. So it will convert uh, all the bands into 1 meter resolution. So remember, we will go to Google Earth Engine. So if you can just search for Sentinel-2 and go to Sentinel-2A, and come to the bands, you will find the resolutions in here. So for the aerosol band, you have 60-meter resolution. For some of the red, blue, green, and near infrared, you have 10-meter, and for rest all, you have 20-meter and 60-meter band resolution. So this particular model, which is s2dr3 for short, and Sentinel 2 deep resolution 3.0, will convert all your images, all your bands, the first 10 bands, into 1 meter resolution. So we will see how we can do this. So in order to know which is a cloud free image, and for what date and longitude latitude we need, I'm just using the Google Earth engine. So it can just rename it as S2, and use a geometry, and you can click anywhere and uncheck this. So rename it as ROI, create a variable called filtered for S2. You filter with the help of bounds to region of interest, and also filter with date. So I want it for the latest, for 2025, February to 2025, February 28. So for this particular data set, I want a cloud free image. So you can use ee.filter dot less than, mention the property which you want to filter. So I want to filter the cloudy pixel percentage to less than 0.1%. So just print this filtered one and click on the run, so to see whether we have the image or not. So we have an internet issue, so it's connected, run. So with for this particular location, for the year 2025 to 2021, I have four elements with a cloudy pixel percentage less than 0.1%. So you just expand the features, and you will find the dates in here: 2025 to 9, 2025 to 14, and 2025 to 24. So all these images are there. So you just come to our Google Colab back in here, and now I want to install the Sentinel 2 DR3 model. So for which we have to come in here, and you select this, and paste it in here. So remember, I want to uh, use this percent capture in order to keep my book clean. So it will take some time. So also you want to change this runtime type to T4 GPU. So because this is some advanced level of model, so it require from high level of computation. So instead of CPU, you just switch to GPU and click on the save. Now you click on the run. So it's connecting to T4. So please wait until it connect to T4, and then the cell will get run. We have some internet issue, so just go to settings. It's connecting to T4 Python 3. So make sure you have the better internet connection. It's still connecting. So my cell is executing, so this will take some time in order to execute the cell, because we are installing two libraries. One is the GDAL bin, so for working with the geospatial datasets, and another one is this s2dr3 model, the Sentinel 2 deep resolution 3.0 model, so developed by Google Gamma Earth, in order to increase the resolution of Sentinel 2 bands to 1 meter target resolution. So let's just hope it's gets done quickly. Yeah, the code is running now, and it is installed. So our GDAL bin with the s2dr3 model so has been saved, and it's connected to T4 Python 3. So let's just import this. So just write import s2dr3 model dot infer. So this is the particular function, the info utils s2dr3, which we'll be using today. So you just click on the run. We should import this library from the Sentinel to dr3. So in order to run this model, we need two arguments. So one is the lonlat of the image, the centroid. So if you can just come back to your Google Earth Engine. So this is the particular uh, point at which we centered around. So you just click on the inspector, and you will get the longitude as well as the latitude. Just select this and copy paste in here. So we have the longitude. So remember to give the long and lat in the XY format. So usually it will be lat long format, but this model will take in terms of longitude and latitude. So also you want to specify the date, the cloud free date from which the model has to take the Sentinel-2 dataset. So that's why I have created this snippet in the Google Earth Engine. I am just selecting this first one, 2025 February 9. So 2025 February 9 is the date. So for this particular date at this particular location, I want my Sentinel-2 image. Just click on the run. Now I have created these variables, and I have the date and long lat. So let's just run this. So remember, we have imported s2dr3, and we have the info utils function. So it will test at a given location of long lat at the date of this one, and give it a run. That's it. Now the model is running in the background, so it is collecting the images from this date on this particular location from the Sentinel-2 imagery. So here you will see the model is fetching. It is downloading 8 to 9 MBs. So see how fast it is. It is getting executed within seconds. So you have a very fast downloading model. So whatever your output will be stored in this particular output layout. So one folder is created called output. IN stands for India because we have the location in India. So if you go to some USA, it will get US as your folder name. So you have many folders inside. So whatever your output will be come in here. So here you see this is our first output. So we have 2025-209 MS, which stands for multispectral. So it is a 10 band resolution with this 10-meter resolution. So you have our second image, which is now processed into 10. So here you find the difference between the two. This is just Sentinel to level 2A. Here you will find Sentinel to level 2A multiplied 10 times. It means the resolution has been increased 10 times from 10 meter to 1 meter. So whatever in the middle you have is the date of the image 2025 February 9, and at the last you have the combination of the bands. The IRP is with the B11, B8 and B5. It means it's for the SWIR band, near infrared band, as well as the red edge band. So for detecting the vegetations, and MS stands for the multispectral band. It has all the 10 bands in here, and NDVI, as you all know, normalized difference vegetation index, and TCI stands for the true color composite, the RGB original band. So which we will see. So now the model is complete. So here you will find the resolution which is increased at this particular equation. So this is the original 10-meter resolution of Sentinel-2. This is the upscaled version of Sentinel-2. So you just click on this link which is provided, so that you will get a preview of what the model has done. The images are loading. So on the left hand side you have Sentinel-2 10-meter. On the right hand side you will get the Sentinel-2 with 1 meter of resolution. You have the multiple columns also, so clearly you can see the difference, how the model has worked, how 10-meter has been converted into 1 meter resolution. So it's a split map provided by Mapbox. So clearly you can see the difference for the true color image, RGB image. And if you just come to NDVI, here also you have the differences in the pixel size from 10-meter to 1 meter. And for the IRP B11, 8 and 5 for detecting the vegetations, here also you will find the clear difference between what the model has done as compared to the previous Sentinel-2 images. So come back to our Google Colab environment. So here you will find the output. It has 8 images. So whatever into 10 is there in the image name, that has been processed 10 times, and you will get the 1 meter resolution band. So whatever this S2A L2A has, it is the original image with a 10-meter resolution. So into 10 is 1 meter resolution. So you have the 4 outputs: IRP, multispectral, NDVI, and true color composite. So remember, you should always download whatever the file you want. If you just close this environment, your output will be lost. So remember to download this and have it in your own personal computer. So I hope guys you have understood how you can upscale the Sentinel-2 dataset with the help of Sentinel-2 Deep Resolution 3.0 model. So this is just the beginning for the Google Colab. So we will come up with the more tutorials and more lectures on how to use the Google Colab, how you can manipulate the basic geospatial data sets in the Google Colab. Everything will be coming soon. So thank you for watching. If you have any kind of queries or doubts, you can always post it in the comment section. uh, Thank you.